Design in Blender, print on an ender. Easy to read visual programming for the purpose of 3D printing. I made a series of neat discoveries, and so as long as I keep it all short, I think it's okay to share my most fanciful one. Though I want to give an honorable mention to the runner-up. My second best idea is to keep math configuration and geometry manipulation apart, preferably by creating two components or groups with well-defined properties, inputs and outputs. First group would contain the bit of math that is always needed to get things aligned right, and the second group, the object or property manipulations that influence the actual geometry. This way, no matter how confusing or messy your math becomes in time, you are still reducing it to just a handful of output properties, which somehow always tend to add up to the absolute minimum of values that are necessary to get your geometry set up in the geometry manipulation group. Now, my most fanciful idea is about dividing design complexity to tame it down and keep things simple and easy to manage and read, both in mind and in software. It requires that you work your way back from the print surface of your 3D printer. Simply ask how many objects are there in your creation and what will require assembly after the print is complete. Because those separate pieces of plastic represent the geometric primitives that you must first create in your program and later decorate. Those primitives are the starting point. Because to tame the complexity down, what you are going to do is start with the primitive and decorate around it. You are starting with the primitive that gets all the decorations to turn it into something you need, that makes the piece of plastic that you later on have to assemble a little bit to complete your print. Thinking like this works really well for creating kits that then can be configured in various ways, like building blocks. The word decoration here is really important, because that means that all you are doing is sending the initial geometry down a single stream or your wire. Since the end result is a single standalone piece of plastic, it means that the stream of geometric information does not combine with anything. So don't share anything between the different streams. All you are doing is applying decorations, or more precisely, geometric transformations to your initial primitive. For example, there are numerous things that feature in just a single superhero belt compartment. The cube primitive, the lid hinge, a handle to easily lift the hinge, a tidy locking mechanism to click the lid in place. Then you have the lower hinge, belt loops in the back, little feet because you can make a jewelry box out of it, why the heck not? There are also slide rails on the side to allow mini accessories, one of which may be a connector that can make a belt just out of connecting all the compartments together. Then there are decorations for the front, some kind of an easy-to-print motif that looks fierce, regardless of how tall the compartment is. There's the hole for the pin that connects the upper and lower hinge together. The hole will need room to inset the pin head now. And the pin should have a tactical looking head and allow for easy disassembly. You see, all of these little bits must be programmed in such a way as to make for an easy-to-follow visual programming program that you can read some months or years down the road, that then you can later debug and improve and never have trouble understanding. Let us take a look at a simpler variation where we only have the box and the lid, a pin, matching hinges, and a hole in the hinges to slide the pin in. When you visualize it on your 3D platter, it is only 3 things: the main compartment, a lid, and a pin to hold the two together. Just 3 things. That means you can start with a cube for the compartment, a flatter cube for the lid, and a thin cylinder for the pin. 3 things. Box, lid, and pin. Can't be easier to remember and manipulate in your mind. See, beyond the primitives, the compartment hole where you put things, both the upper and lower hinge, the hole within the hinges are just decorations that you apply to the primitives as you go forward. 1. The main compartment cube gets decorated with a compartment hole, and then a lower hinge and a hole through the hinge. 2. The lid gets decorated with a matching hinge, and again, a hole through it. 3. That is your pin, which in its simplest form is an undecorated, thin cylinder primitive that slides into the hinge hole. For those of you who are wondering about the holes for the pin, yes, those are also cylinders, ever so slightly larger than the pin to make a good friction fit. But hole cylinders use Boolean geometry modifiers. They are subtracted from the hinge. In closing, I would like to explain that this decoration flow or process calls for 2 separate hole cylinders. Even though, if you really wanted to mix things up, you could just totally make one and then somehow crisscross it between the 2 different flows of decorations. Do not do that. One is to subtract hole in the lid hinge, and the other must subtract a hole in the hinge of the main compartment. You should absolutely make 2 separate cylinders. These are 2 different process flows. Think of them as being taken care of at 2 different factories that do not know about one another. Here, we are creating a separate line of decorations. One for the original primitive that started making the lid, and one for the cube that started making the body or the compartment part. This creates a single, easy-to-comprehend line of decorations for each of the components. Reusable components are fine, but they must be instantiated separately and far and away from each other. The point is to always create a single long line that starts with the primitive and ends with the well-decorated piece that then gets printed out on the printer. Double up. 1 fancy insert pinhole for the upper lid and 1 fancy pinhole for the lower lid. I know that it may seem quicker to just reuse the thing in 2 places, but a year down the road, this will make for spaghetti code. It is very important that the decoration process is one long line. This way, even if years pass, you will still be able to read your code. You will still be able to understand the decoration process. and easily add or even remove decorators without damaging anything that has anything to do with other parts. And to help you remember it better, here it all is in a single short sentence. Do not cross the geometry streams. We are talking here about a total protonic reversal. Or something.